Good afternoon, everyone. Let me just get the old PowerPoint up and running. So this is a picture of this is a website called Bing. Bing's a really nice search engine, even if you like other search engines. The best thing about Bing, apart from the fact it's a great search engine, is every day it has a beautiful image. Lots of people I know have actually submitted images to Bing and had it show up on the homepage. And I saw this one the other day, and I thought this is quite a good topic for demystifying the Internet of Things, because this little fellow here looks like he's got a bit of a challenge understanding what's going on around him with the look on the face. So anyway, before we get going, just out of interest, how many of you would say you are already an Internet of Things company or developer, or you're in the ecosystem in some way or other? Just out of interest, so probably about two, maybe just over half. Of everyone that's interested in Internet of Things that's obviously here, what about those of you that would say your primary interest is consumer stuff like wearables or something that you would sell to end users? Okay, hardly any. What about business to business then? Industrial or enterprise or whatever? Okay, so quite a few more. Excellent. Oh, that's interesting to know. So I think that the first challenge in demystifying this topic is actually defining what is the Internet of Things. And for a lot of people, if you stopped 10 technologists in the hallway at a major conference and asked them what it is, you'd probably get 7 or 8 different answers. So it's worth thinking about Internet of Things as a sphere that's going to change as it gets more and more mature. And it's not the first time that sort of thing has happened. So there are a number of, if you will, mega trends that have happened in the IT industry and in consumer adoption of technologies over the last maybe 10 years. Mobility is one that's obviously changed the way that a lot of us work. This is the idea that you could take a laptop and work away from the office. It could be that you're using a mobile device like a phone or a tablet or something, and you're doing work-related things on it whilst you're sitting at home watching The Apprentice on the sofa. So there's all kinds of means that you could, things that you could call mobility. And when this kind of technology first started really getting a hold, lots of companies would have a mobility strategy, and there'd be mobility solutions providers and technologists that would define themselves as being, we do mobility. And yet now that's all just kind of vanished into the background. Nobody has a mobility strategy anymore, more or less. It's just the way that things work. And IoT is going to go the same way. We won't be talking about IoT as if it's something different in 2 years, 3 years, 5 years. I don't know quite what the frame of time is likely to be, but it's probably going to be sooner than maybe we think at the moment. Social is another one of these things that, again, a few years ago, you would define something as, well, that's social computing. It's different to regular computing. Now, from an end user perspective, social networking, social computing is kind of bound up in the way that a lot of people use computers at home particularly. But from a business perspective, it's very relevant in terms of how you reach out to those users, how you do marketing, how you build your own brand. And in the early days of social computing and social networking, you would have a lot of social consultants that would advise businesses on how to get that online presence. And that's still still quite a growing area now, still a burgeoning market. But it's one of those things that in time will just become the same it's an online presence in the same way that nowadays you don't need to convince a business they should have a website. They just assume that if you don't have a website, then they're probably not in business. You don't have an e-commerce strategy anymore if you are a company that sells things. You just have a commerce strategy that includes some sort of online retail or that sort of thing. Cloud, another great big technology area that's probably 7 or 8 years ago first started getting used by marketeers as if it's something new. And yet technologists have been talking about putting things in the cloud for donkey's years. I mean, email in the cloud goes back to Hotmail in the mid-90s, and it's the same sort of thing with all kinds of other applications that happen to be online. Storage happens to be available wherever you are. And when you combine that with mobility and other things as well, it starts to change the way that we work. So cloud is a real empowerer in that it gives access to world-class technology to people that otherwise wouldn't be able to afford it. And that itself is a change that's affecting the way that pretty much all IT is going. In 5 or 10 years' time, you might look back on the day where you bothered to have computers on your own office or your own premises as pretty, it's an anachronism. In the same way that you would never think about, I need some electricity, I know I'm going to go and buy a generator. You'd think, I need some electricity, I'll get it from the electricity company, and maybe I'll have a generator in case that goes down. That's going to be much more the normal way of doing things, and it's a change that's accelerating now as more and more organizations that historically have been a bit maybe reticent to get into cloud computing are embracing it when they see what difference it can make for them. Now the final one I put on this thing as a mega trend is big data. I've seen all kinds of little memes on Facebook, one of which was the scene from Pulp Fiction when Samuel L. Jackson has got the gun in the guy's face and he's saying, "Say what again?" And the guy's like, "What?" And it had been dubbed to say big data again, because there's just too many times you read about how big data is transforming the world. And another interesting one was somebody put up a slide in a conference I was at, and it said, "Big data is like teenage sex." Everybody's talking about it. Everybody thinks that everyone else is doing it. Nobody's really doing it, but they're all talking about it because they think that everyone else is doing it as well. And it's a similar sort of thing where it's just one of these areas of technology that everyone kind of gets that it's going to be really disruptive and it's going to be really enabling, but it's just not quite there yet perhaps, but it's kind of on the cusp. So like I say, I think Internet of Things is going to be one of these things where it will just blend into the background and we will stop thinking of it as if it's some kind of special sauce technology on its own. Instead, it will just be capabilities that are there with everything else. And interestingly, the guy who coined the term was this chap here, Kevin Ashton. He worked at a number of industrial organizations and also did some work with MIT. But his premise was that everything that's on the internet is by and large been put there by a person. And that in itself is immediately flawed. You know, if there's a picture on the internet, it's because somebody saw a picture and decided to upload it. This was some years ago that he made that initial assertion. And then he's updated it in this paper that he did in 2009, which essentially said, imagine this world where machines out there just know all about each other without us having to be involved to set it all up. And they can find out information that's relevant to keeping them healthy, keeping them secure, keeping them available. And ultimately, that's what this is all about. You know, what is the reason why anyone cares about Internet of Things? It's generally because they want to achieve something like make the systems more efficient or save money or provide some additional capability that otherwise isn't really all that feasible because there's too much human intervention required. And this is basically the nub of why we think as an industry this is going to explode. And the numbers are crazy. I mean, if you ask a number of different analysts, you'll get all kinds of different responses here. But you know, some of them have said, this was Ericsson and also Cisco have used this number a lot, that 50 billion devices are going to be connected to the Internet of Things by 2020. It's always seemingly 2020, you know, it's like 5 years away. What it'll be in 3 or 4 years' time, who knows, but 5 years away, 2020, 50 billion devices. And in fact, that's not the lowest number, not the highest number even, 75 billion from another analyst, and in fact, IDC trumped the whole lot by saying 212 billion devices, and the market will be worth nearly $9 trillion in 2020. Now, this is how do you define what the Internet of Things market is? You could say everything that's got a sensor in it and is maybe connected to other devices is part of the Internet of Things. And maybe that's true. So maybe the whole Internet of Things is a real misnomer as a way of labeling stuff, because most of the devices that will form the Internet of Things will not themselves be necessarily connected to the internet. You know, they're not all going to have an IP address. They're not all going to be available for attack from some bad guy out there on the internet. Most of these things are going to be connected to some other system, and it may be that that system, indirectly or otherwise, is itself connected to other things over the internet. But it's not the same thing as saying we've got 200 billion IP addresses to go and infect or play with or steal data from. And that's maybe where some of the concerns amongst people who don't really understand this area kind of come in, when they think, we're not really sure if we want this because, you know, isn't the internet bad enough on its own without all these billions of other devices that nobody knows about? So when we think back to the rationale as to why anyone really does care about this, the big driving force really is all about getting access to data. And a standard pattern would be, you know, you've got some kind of embedded device, maybe there's an application that's running on that thing, or there's an application that is able to retrieve data from that device. So the device itself might just be a sensor. It could be a temperature sensor in a room like this. And all it does is, you know, wake up every so often, send the data that it's reading to something else, and then shut down again. And that something else is running some kind of application that's doing something with the data. So maybe it's just collecting it, it might be storing it. Every so often it might then pass that data on to something else. So other scenarios where this could be an ideal would be you're driving along and maybe in the future we'll all have electric cars. You'll be driving along in your electric car, it'll be bristling with sensors, and the car will be collecting data all the time. Some of the stats in this already are just absolutely mind-boggling. A terabyte of data per day per car is what some of the car manufacturers expect that these things will be able to collect. So they'll be collecting telemetry, what they sometimes refer to as digital exhaust. It's just spewing out data from all these things. And on their own, they don't mean anything. It's just, the actuation of the accelerator, how the brakes are working, what angle the wheel was at, all that sort of stuff individually is meaningless data. But when you collect it all together and send it somewhere, and that connectivity might be over the radio. So if the car's driving along and it sees there's something really significant, it might send that fact. It's just hit something on the road that looks like a pothole. It might be able to report that immediately and say, here's my location on the road. But if it's just sitting parked up quietly in a side street, it's not going to need to connect to anything. Maybe what happens in the electric car scenario is you get home in the evening, you plug the car into charge, and it detects it's got high bandwidth internet connection, and that digital exhaust will just get hosed straight back to the car manufacturer, and maybe anonymized in some way, and then they'll be able to use that data to figure out exactly how the car is being used, exactly what components are doing what, and they might again go back to the manufacturers of those components and say, your brake pads are wearing out too quickly, or your motors are running too hot, or whatever. So there's all kinds of ways that information might be useful to other people than you, or in fact the car manufacturer directly. But let's say the data gets sucked up into some back-end system, and in an enterprise world, if you're running a fleet of trucks or a coach company, you would obviously have some sort of system that would want to know where these things are, what they're doing, maybe where they're going, what they've got on board them, and all of that sort of information will help you plan the fleet more effectively. And it doesn't really matter what scenario you apply this to, you've probably got something that's coordinating the world at large. Where are my things? Where are my people? What are the people doing to those things? Is that a problem? Is it something I need to intervene? Do I need to tell the thing to do something differently? So maybe as part of this data gathering, we'll make decisions that say we need to change the behavior of that device that's out there. We need to tell the driver to go somewhere else. We need to turn down the level of something that's happening in the field. If it's a utility company, maybe we need to shut a gate to stop a pipe overflowing a river, or we need to open something up to stop it doing something bad. So that device updating and device management piece, again, in every industry it will have a slightly different way of manifesting itself. But ultimately, this is a great big feedback loop. So from a technology perspective, there are quite a number of discrete bits in this pattern. I sort of apologize for this because I hate it when people put up slides with loads and loads of text and say, sorry for the eye chart. But this is in there because I'm guessing you're going to get a copy of these slides, and it's quite a useful kind of reference card. But the bit to pay attention to, if anything, is this diagram down in the corner. So we could basically break down any Internet of Things application into a number of key components. So the major ones are, there's a dumb sensor. This is the temperature sensor in the room, and it wakes up once an hour or once a day or whatever, senses the temperature, somehow sends it over a radio or a wire, and then goes back to sleep again. And that thing might have a battery in it that will last 10 years. It might have mains power. It doesn't really matter. And that's going to send that data to somewhere. Now that somewhere might be itself a collection point. So you might have smart sensors that have, in fact, a temperature sensor, a humidity sensor, a vibration sensor, a bunch of things, and then that thing will collect these readings and be able to make some assertion based on them. And again, it may just say, there's nobody in the room, and the windows aren't open, and the heating isn't on, and it will go back to sleep again for another hour. Maybe those sensors will actually be sending data to something that's more akin to a concentrator or a hub type device. And that's maybe going to be able to do a lot more processing of the data. So in the car analogy, the sensors might be the thing on the wheel that says it's turning round, or the thing on the brake pad or the brake pedal that tells you that you're pressing it. But the hub is the control system of the car that's coordinating everything that goes on. And that might in turn be doing very localized processing that will alter the way that the environment is in that car. And again, as I said earlier on, it may well be sending data back up the line in real time, or it might be doing it after the fact, and then that data will be collected and dealt with later on. But in principle, there's an infrastructure component here where just managing all of these things, managing the sensors, managing the hubs, deploying software out to them, that itself is a big problem, especially when you get into volume, especially when you think about the challenge of managing 50 billion things. You know, when was the last time it reported its reading? Has it got the same level of firmware as everything else? What if you've got a lighting system at home and your neighbor has the same lighting system? How do you bring on a new thing into your environment and make sure that it doesn't conflict with what your neighbor's doing, or he doesn't buy something and then suddenly it shows up in your dashboard and you can control it? All of that is a problem that needs to be solved. And this is where a lot of the action, I think, is in Internet of Things technology in the UK. It's building the things, building the sensors, building the control modules and the hubs and the electronics and the firmware and the software and the services that support all of those things, and providing some way of controlling them. Most of the people that are buying into Internet of Things at an enterprise level don't really care about any of that. They don't really care about who makes the thing, who makes the sensor, what form of radio communications it's using. What they care about is the data that they get back from it. So they want to take this data and do something with it. If they are BMW, they want to take the data from the car, and it doesn't matter how it got back to them, as long as they know it's valid data. Then they could start doing some kind of analysis on it and look for insight. And this is the key point of it. It's what insight can they derive from all of that data that will make them more effective, that will tell them when there's a problem that is going to happen before it becomes that problem. So I've been doing some work with quite a lot of companies in the UK that themselves are providers in this space. So my job at Microsoft is to work with independent software vendors that are building something that they offer as a service. And there's quite a number have got Internet of Things type infrastructure services. And those guys themselves are, they're working with really interesting scenarios of customers. So one of them is a company that does condition monitoring for airport baggage systems. Doesn't sound very exciting. However, if you were at Heathrow Airport last weekend, you might have realized just how important baggage systems are. Because if you can't get a bag through an airport, you can't land a plane, and you can't let planes take off with bags on them. So it's a mission critical system. And what these guys basically do is they monitor everything that's going on in the baggage handling environment, and they tell the airport, fix that, change that sprocket in that machine now, rather than wait for it to break. Because if it breaks, it will take the whole belt out, and that means the machine's offline for a day, or else you fit a new belt, and that means blah, 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 blah. So they try and get ahead of the curve by saying, a little bit of 5-minute maintenance will save you a lot of money in the long run. And the service that this company provides those airports, although it costs the airport quite a lot of money to get that service, it saves them far more money in downtime and other unexpected expenses. So, I've used a couple of examples here, but there are all kinds of them. And you could throw these up and say, for every vertical scenario, whether it's manufacturing, whether it's fleet management, whether it's playing at home with switching the lights on and opening the curtains and all that sort of stuff, there are different levels within those applications. And I like to think of them as little data, big data. Little data is probably stuff that's relevant to you or to the immediate environment around these things. Big data is things that perhaps will have a greater value in the long run. So take health monitoring as one example. I wear a Fitbit on my wrist. That Fitbit synchronizes with my phone. It puts the data in the cloud. I get to see how active I've been. Maybe that data is going somewhere else as well. I maybe have a control over that. But that's really about it's for my benefit, which is why I bought the thing. If I was diabetic, there are diabetic monitoring systems out there, which mean I can get a reading several times a day of blood sugar and insulin levels. But the interesting thing with that sort of data is health insurers and people like that could start collecting that data at mass and be able to then determine how effective the drugs are working, or determine whether the medical professionals are intervening early enough when they need to. So that's where you could collectively get lots of data together and do things that are genuinely game-changing or genuinely interesting. Examples like building controls, another one where at a simple level you could have a security camera that's streaming video out onto the web, or you could have lighting that you can switch on or off in a commercial environment. So I know if there's no one in the room, switch the lights off after 20 minutes, save some electricity. But at a level where you might have lots of buildings, being able to do this at scale is a really hard thing. There's a very interesting case study known as 88 Acres, and it was done by the facilities management group at Microsoft at our corporate headquarters in Redmond in Washington State. Now we have this campus area that is, well, probably 88 acres. It might be a bit bigger than that now. But in that area, there are buildings that are 20 years old and there are buildings that are 2 months old. And every single building control system that's ever been made, there is at least one version of it running somewhere in that environment. Just because whatever was current at the time the building was put up, that's what they bought, that's what they installed, the wiring, the controls for everything. So being able to manage the whole thing holistically was really, really, really difficult. But we got together with a software company called Iconics. Iconics wrote a kind of abstraction layer to each of these building control systems and provided a uniform interface. And what that meant is that by the end of the project, there's one control room in the whole of the campus that can do the same sort of controls on any of the buildings, regardless of what system they've got. And that saves us millions of dollars a year in making sure the aircon's working effectively, making sure the lights are on or off when they need to be, making sure that heating's not on and the windows are all open, all of that kind of thing. So there are loads and loads of different examples of this, and I'm sure everyone's got their own pet topics that they work in. From our perspective, we think that the cloud is the thing of interest. So in the stacks diagram that I put up earlier on with sensors and hubs and communications networks, and then maybe several different applications that are connecting to the data, there are different ecosystems at play. So in the UK, particularly in Cambridge perhaps, there's an awful lot of activity going into building the hardware, using Raspberry Pi, using Arduino and variants of that, building things that are smart that can connect using low power radio and send data. And that's a necessary part of the overall system. There's a lot of companies out there that sell connectivity services, whether it's long range stuff, whether it's cellular networks, whether it's connecting using Z-Wave and Bluetooth and things like that. They've got solutions that help to do those kinds of things. And that's all necessary as well. But from an application perspective, the sensor that's reading the data, from a software perspective, does not give a damn how the data is going to get back to where it's being sent to. It doesn't matter to the application architecture what frequency the radio is going to use, or whether it's going over Wi-Fi or wired networks or what. It's still the same pattern of behavior. And from a cloud perspective, again, it doesn't matter where the device is, the application that's collecting this data and the application that's using it. It doesn't matter how the data got to it. So the interest that I have in this whole thing is because we think that the cloud is the bit that's the hardest to do at any kind of scale. So we built an international cloud network called Microsoft Azure. It's got data centers all over the world, and we're opening them all the time. So there's a couple just opened in Australia. We're the only public cloud provider in China. We've got one in Brazil, there's another one coming on stream. There's a couple in Europe. The point of this is basically that developers who are looking they've built their thing, they've built the device, and they've got the radio module. The next step for them is, what do we do with the data? How do we get the data off this device, and how do we do analysis on it? And we're looking to make it easy for those kinds of companies to get themselves up and running. And these data centers are at a scale that you just wouldn't believe, and I genuinely mean that. You just would not believe it if you walked into these things. I was at the Dublin data center in, well, it's that picture with the glass box in there. I was there about a year ago, and the servers that these guys are racking up, and I'm telling you, it's like the end scene from Indiana Jones, where the camera pans back and it just goes on into the horizon with a little guy pushing a crate up the middle of it with the Ark of the Covenant in. That's what the data center looks like when you're inside of it. And each of these racks is just populated full of servers and disks. And the servers they were racking up had 128 cores, a terabyte of RAM, a 10 gigabit fiber network to the backplane, and there were just racks and racks and racks of these things. So we now have more than 1 million physical servers in this cloud environment. Now, what that basically tells you is you need to have a hell of a lot of money to do this properly. And there's probably only 3 companies in the world that can do it, and those are Microsoft, Amazon, and Google. So any of these 3 companies are playing in this space, looking to see how they can apply their considerable resources to make life easy for people to get data into their environment and to do computing within it. Now, from an application perspective, the traditional sense might have been, you run everything. So you buy a box and you put it under your desk, you install your operating system on it, and you're responsible for everything in that box. If it goes bang, that's your fault. The cloud model is one whereby if you get into running virtual machines, then obviously somebody else is taking care of all the hardware and the storage, but you get a VM and you still install your software on top of the operating system and everything else. So you still have to make sure it's up to date and configured properly and patched and yada, yada, yada. But as you get further towards the right-hand side of this, more and more of the infrastructure gets abstracted. So, cloud services basically means you don't need to worry about how any of this stuff works. Just deploy the configuration of how your bits will all talk to each other, put your data, put your applications out there. And then the further example, like a website, is you don't even need to know how many servers it's running on. If you want your website to scale up, you turn the volume knob up, and somehow or other, magic happens and servers get configured to share the load. And that's the goal for a lot of applications, where they might need to have really high capabilities of ingest of data and of processing it, but they don't want to be funding machines hanging around waiting for that to happen if they can avoid it, if they know when it's going to happen. So these things are all patterns that you see in any of the cloud environments. And I guess the thing that's driving our interest in Internet of Things is about a partnership proposition. So Microsoft, from its very early stages, was a partner-based company. We don't try and do everything. We build technology. Other people use our technology to make interesting solutions, whether that's building hardware or increasingly building software that's running online. And the proposition that's getting a lot of interest at the moment is this idea that Internet of Things doesn't mean you start with a new thing. What it could mean is you take the things you've got and you retrofit means to measure the data from them. So I like to think of data as being like almost like an ether that's out there. There's a latent data everywhere. The status of every physical thing could be measured. It probably isn't being measured at the moment. And the systems that are installed today to measure those things, to know about the lighting, to know about the temperature, to know about the whereabouts of the trucks or the buses, those systems historically have been silos where the company that installed them did everything from the hardware all the way up to the software, and it only did it because it made them be able to operate that system. What the Internet of Things is allowing us to do is to break down those silos and suddenly be able to share information in a way that maybe wasn't originally understood when the system was first built. So we're seeing some really interesting case studies where companies are saying, well, we've got all this stuff out there, we've got all these assets, how do we monitor the assets so that we can then derive meaning from them, derive more insight from them? And examples of that could be things like CGI, consultancy and software firm, has done a project with the London Underground. And they're doing stuff like monitoring escalators and lifts. Doesn't sound very glamorous, but knowing where these things are, knowing what load's being put on them, again, helps them to do preventative maintenance. So it saves the London Underground money, and it gives them better insight as to how people are moving through the stations and that sort of thing. So you don't need to think about Internet of Things as being, first of all, I'll install lots of sensors that are brand new, and then I'll wire them all up. It could be taking equipment, taking existing assets, and then somehow enabling them to share their data with the outside world. So with that, I suppose the summary here is it's going to be big. Nobody really knows how big, but it's going to get really big somehow. I believe that IoT as a term is going to disappear into the ether. Consumer Internet of Things is the thing that's getting a lot of people excited, maybe less so in this room, but looking at the conferences in Las Vegas, like the CES show, every device was an Internet of Things thing, and wearable technology and all these other consumer trends are driving an awful lot of written words about this area. But in truth, it's enterprise Internet of Things and industrial Internet of Things where the money is, and that's what's going to drive the innovation more quickly. And then finally, like I said, Microsoft's interested in this area largely because we've got a large number of partners that are doing the last mile, and we're interested in how we can help them do that. So if you're a partner of ours, if you're not a partner of ours and you're doing interesting things with IoT and you want to talk to us about how we can help you, then grab me at a break or something, and I'd love to have a chat. So with that, we've got some time. We've got about 10 minutes, I think, for Q&A. 15 minutes.
So thank you very much, Ewan. I'd now like to introduce you to Henry Tucker, who's Editor-in-Chief at BCS, the Chartered Institute of IT, who will compare questions from the floor as well as post some questions we received in advance of the conference. Very much gratitude for the amount of questions we received. We'll try and get through as many as we can. By the way, for people standing at the back, there are lots of spare seats at the front and in between people if you'd like to take a seat. So if you have any questions for Ewan, please do raise your hand, and Becky, who's at the back in the red coat, she'll give you a roaming microphone so you can state your name, your company, and proceed with your question. So I'll now pass this over to Henry.
Thank you, Ian. So, Ewan, we'll kick off with one question that was sent in beforehand. So, one of the main things about Internet of Things is the privacy. So, how much privacy do you think users are willing to relinquish in order to reap the benefits promised of IoT?
That's a great question. So privacy, data ownership, actually, maybe more than privacy, is the elephant in the room as far as the consumer Internet of Things world is concerned. Most people, if we won't do a show of hands. Whenever you get the pop-up on a website that says, "Do you accept?" whatever it says after the "Do you accept?" Do you bother to read it? Do you just go, we're going to use cookies, and you go, get out of the way. We're going to use cookies for, demonic aims, and we're going to own the rest of your life because we put a cookie in your PC. You just hit accept. So most users, when it comes to being asked, is it okay if we do this? They're just going to, just get on with it. That's why I'm here. That's why I'm using the service. That's why I want to buy a thing from it. That's why I want to use the fitness band or whatever it is. Probably what will happen is situations will occur where companies will use people's data in ways that the people didn't ever expect. And then there will be a backlash against that company. And then, that will get in the press and people will complain about it, and then additional controls will come along and so on. So how much data people are prepared to give away is probably an open question that I don't think anyone can really answer all that honestly. And in terms of my own data, I don't want to give data that's too specific about what I'm doing to people that I don't know and don't trust. But those definitions are, they're really hard to do. So, when the Nest Thermostat was launched in the US, lovely device designed by a bunch of guys that were ex-Apple, so they really had industrial design right down to a T. They built this thing that was beautiful, had a lovely software environment. It managed to learn when you were at home. It switched the heating on before you got home. All of that stuff, all great. You think, as a consumer, that's brilliant. That's just what I want. Makes my life better. Then our friends in Mountain View, Google comes along, says we're buying Nest, and quite a lot of people on the internet started saying, well, hang on a minute. I was prepared to say, I'll give people that like Nest the benefit of the doubt, and we'll let them in, and I'll share with them information about where I am and when I'm at home and when I'm not. But if another company that has maybe different aims and different patterns of use for data comes along and starts using the same stuff, then maybe I'm not so happy about that. So, like I said, it's probably going to take a backlash of people saying, I don't want this to happen, for real controls to be brought in. But the government's looking at how we can control this environment, if at all. And the challenge then is if you put too much in the way of control, then it will stifle innovation and creativity, and people will not want to use it at all.
So do we have any questions from the floor? Anybody?
Hello, across the whole IoT ecosystem, who would you say is really killing it? Who's doing really well? Who do you admire?
Nobody.
Cool.
Not even Microsoft.
Nobody is really killing it yet. There are lots of companies out there with great ideas. There are lots of companies out there with a great idea, and they think they're the only company in the world with that great idea. And then they realize that companies with great ideas are 10 a penny. Companies with great ideas and the means to put them into reality are hen's teeth at the moment. So again, I would segment consumer IoT and enterprise IoT as separate things for the moment. And there is crossover from a technical perspective. The technology that you might use to do a smart home isn't all that difficult. It's not that different, from a technology you use to do a smart building. And then smart cities are really just smart buildings connected together with smart transport and smart power and all the other things. So the building blocks are all pretty much the same. But the way that you adopt those technologies is going to be very different depending on where you're coming from. So consumer IoT has a lot of interesting things going on right now. Fitness trackers and quantified self, as Gartner calls it, whereby you're using technology to measure your own self and then give you data about what you've been doing. That's a really quite well established world now. So you've got the Fitbits of the world. Anyone who's really into cycling will almost certainly have a Strava account. And if you've got a really expensive Garmin cycling computer, like anyone who's really into cycling probably will, then you probably connect that up to Strava. And it's really great because it will tell you things like, when you went out on your bike ride, here are the segments that you did, and here's what everybody else did in the same segment, and here's the league table of how you stack up against your friends. And that's all really cool. And it's worth hundreds of pounds to each individual. which is why they do it. When you take that and think about how that appeals to someone that doesn't have the money to spend on these kinds of things, how it could be used in an environment like social housing, where the people that live in social housing by definition are probably the ones with the least disposable income to do stuff like that. How could we use technology to make their lives better? Maybe by saving them money, maybe by providing means for the social housing providers to better use their resources and so on. And that's where the challenge is going to be really. And today there's a lot of stuff being played with in there. There's a lot of research being done, but there's nobody who's, to use your term, there's nobody who's really killing it yet, I don't believe. Happy to be proved wrong, but...
Any others at the moment? Any others? Well, there's another question that was sent in, following on from you saying about the smart home.
Yeah.
So websites talk about monitoring when Timmy comes home, the lights go on and push notification to mum that he's home safe. This is all seemingly rules-based. How much research into AI and habit learning is there, and is this an area people see taking off?
Sorry, how much is AI?
AI and habit learning. So,
okay,
so we get, it's automated or learning, as it goes.
It is certainly something that has taken off to a degree, but it's in the early adopter sphere where, in smart home world, people with a relatively high disposable income and a relatively high tolerance to things that don't always work tend to get into these things. I was dabbling with X 10, 15 years ago, and I can tolerate that when I press a button and it doesn't come on, I scratch my head and I think, now, why did that not come on? Let me go and troubleshoot it. When the rest of my family comes in and they press a button, the lights don't come on, then I get shouted at for breaking the thing that used to work, which was a light switch that made the lights come on. So AI, learning, all these kinds of things are certainly being adopted, and I used the example of Nest, which is a good one. British Gas have got Hive. That was developed by a UK company who did all the technology behind the scenes, and they're trying to sell that to other people in the world. Essentially, it's the control aspect is the thing that's still got a question mark for me. So most people will adopt this technology and they probably won't bother giving it any real controls. They'll set it up, they'll have it installed, they might leave all the defaults on, the username and password will still be admin and a blank password. They won't necessarily know how to deal with it, or they won't really care enough about it. If we're not careful, then those kinds of systems could end up putting data in places where you probably wouldn't want it to be. And by the time it's out there, it might be too late. So, it sounds a bit of a doomsday scenario. I'm really sorry to put a bummer on the whole day like this, but I genuinely think that consumers really need to be understanding better what's happening to the data that they are generating. Now, I had an interesting way of putting this a couple of days ago at a meeting of a group called the Digital Policy Alliance that's basically advising the government. And one of the guys said there's two types of personal data. There's personal data and there's private data. The personal data is data about you that you don't mind other people knowing. Now, you could argue things like my location at any given point in time. I don't really mind if people know that. Obviously, there's going to be constraints. I don't want everyone in the world to know that, but I may be able to say I'm happy to share that with people that have a vested interest, or that I have a vested interest in them knowing. So if I'm driving a car and my insurer has said to me, I'm going to, they want me to install a box in the car or run an app on my phone that reports back on regular intervals where I am, what time I'm driving at, how fast I'm driving, all that kind of stuff. They might well turn around and say, we won't give you insurance unless you do this. So I've got a vested interest in sharing that data, otherwise it would be uninsured. But I don't necessarily want it to be published in the outside world. And that's personal data. Private data is stuff that I would not want anyone to get hold of, like maybe medical records, and even more specifically than that, maybe medical conditions. If you suffer from a given medical condition that might affect your ability to function, but you've got it under control, you probably wouldn't want other people to know about that unless it was really relevant to them. So there's stuff like that where there's a dividing line of data that you don't mind sharing, but you'd still want to control it, and there's stuff you definitely don't want to share. Now, the interesting aspect here is if you imagine IoT as a world that is connecting things that used to be silos of information. So again, I've given a number of examples of systems that have been around for a long time. 20 years ago, I was working in the utilities industry doing telemetry systems for water companies. So they were monitoring the water network and where water is, how fast it's flowing, how high the levels are, all of that kind of stuff. And you had all the same sort of things that you would see in an IoT environment today, raising an alert when something goes out of bounds, general reporting over time. That's not new. Machine-to-machine learning, machine-to-machine communications is not new. A lot of the things that are now lumped under IoT have been around for ages. The way they're different is because of the fact that you can break out of the silos maybe more easily. And that's a good thing in most cases, as long as you've got it under control when it's broken out. If you start saying things like, I've got somebody's whereabouts and what they were doing with their mobile phone at that time, who they were talking to if they were on a phone, or what website they were looking at if they were browsing it, and combine that with other forms of data from other places, you could build a picture up that you might not necessarily want to share with other people. So, be able to understand if you are away from home, then does that mean the house is empty? Does it mean that people could come and break into the house and not get found out? All these kinds of things are areas that are, again, a little bit doomsday scenario, but we've got to watch out for that.
So, any other questions? Yes. Sorry, could you just wait for the microphone? Thank you.
A lot of the companies that you've mentioned are very large corporates, utilities or car manufacturers. Yeah. How accessible do you think IoT will be to smaller organizations?
So it's a good question, because I think at the moment, the reason why I talk about big companies is largely because they're the ones that have got the most to gain from investing in it at the moment. So if I had a fleet of 2 million cars out there, then every penny I could save in developing the next car is going to be worthwhile if I'm a car manufacturer. But the whole point of this technical evolution, and it's partly down to things like easy accessibility of sensors, the standardization of protocols and of data interchange, which is inevitably going to happen, the easy accessibility of software services that are inevitably going to be in the cloud, and then of other things that let you do stuff with that data. All of these things are relatively low cost now, or they're getting to the point where they will be low cost. So the point of being accessible is much closer than probably is for a lot of other world-beating technologies. So smaller organizations will be able to take advantage of these technologies, possibly unwittingly. Like I said, I keep banging on this point that IoT is just going to vanish and it'll become the normal way of doing things. You'll get to a point where in a few years' time, you'll buy a system, you'll buy a security system, or you move into a new building, perhaps it's rented out from a landlord, and the systems in there will by definition be Internet of Things, because they're controllable, you can get data back from them, etc., etc. So we'll probably come across it without realizing it, in the same way that a lot of people use cloud computing without realizing it. The same thing I think is probably going to happen with IoT. You won't go out of your way to say, I need some IoT. You'll just buy a service or a thing, and it will happen to have that technology behind the scenes. It's interesting, actually, that one of the points of differentiation between what the UK is doing and what other countries are doing around the world. Europe is seen by a lot of the world as a hotbed of innovation for IoT. And partly that's because it's a smaller environment that's a little bit more like a pressure cooker one, particularly in the UK, where it's big enough that you can do stuff at scale, but it's small enough that there's not too many big players that will fight with each other till the death. Whereas in America, there's just far too many players, far too many utility companies and people with vested interests, that it's stalling innovation to some degree. But in the UK, there's a lot of effort gone into building an IoT industry that means let's invent a technology that is IoT. Whereas in Germany, there's a lot more effort gone into taking IoT technology and looking for applications for it. So Germany has a collective thing called Industry 4.0, which is a government-sponsored initiative with manufacturing companies and all kinds of people that are basically saying, we've got this scenario like operating a fleet of manufacturing cars or whatever, and we think there's technology out there that can bring us benefit. Let's identify what that technology is, put money into helping put money into helping develop it, put proofs of concept out there, get it rolling. But the goal is a specific endpoint of, we want to use it in this way. Whereas in the UK, it's kind of, hey, let's all invent some cool technologies and then we'll figure out what to do with it later. And somewhere, the sweet spot's probably somewhere between those two. And we'll get there, but it's just going to take time.
I think we got a question over here. Thank you.
Hi. Ewan, that was a fantastic presentation. It was very thought-provoking. Thank you very much indeed. And it's kind of a way of looking at Internet of Things that I think helps people put it into perspective. So thank you very much. clearly what you're saying is it's a very complex ecosystem with lots of different levels within the value proposition and lots of different technologies and companies interacting. The question I would ask is, where do you think the biggest commercial opportunity, the biggest business opportunity is within the value chain? Where is the money to be made? Where are the areas of the reverse where there is very little money to be made and actually the technology is needed but no one's going to make money out of it?
Okay, that's a fantastic question, really is a great question. And I guess if anyone in the room is an investor, or if anyone in the room has got a business that's part of that chain, and you're looking to think, am I in the right place, then that's something you definitely need to think about. If you look at the different stacks, I mean, so let me just, if I may, let me just go back to this this diagram that I put up, and in fact I'll maybe even zoom in on it a bit. Sorry. If you take that diagram there, money to be made at the sensor level is trending to nothing. Right? So there's bugger all money at that level, if you choose the French, unless you can shift billions of these things. So that's where companies like, some of you might have heard of a company called Newell, Cambridge-based company, pioneering and transmitting data between gaps in TV spectrum. Newell was born out of an organisation called Cambridge Science Radio, that themselves were an early innovator in Bluetooth. So CSR made a lot of money out of selling billions of Bluetooth chips at $0.25 cents each, or whatever they made on it. So there is money to be made there. Chances are, if you're not already in that market, the door's probably closed unless you've got something really revolutionary. The same thing's probably true of smart devices and to some degree hub-type devices, unless you've got something that's relatively low cost that could go at really high scale. So I was talking to somebody else earlier on about social housing again, quite a relevant topic really in this area, because a lot of, there's something like 3 million people in the UK live in social housing. And like I said, they're the ones who are maybe least able to afford to spend money on discretionary purchases that makes their life better. In fact, they're the people that are most at risk of falling into energy poverty. They've got the equivalent of a coin-operated electricity meter that is the most expensive way of buying electricity versus someone that pays on a direct debit every month and gets it at a better rate. So to be able to appeal to those kinds of people, the devices need to be ridiculously cheap. And at the moment, they're not there yet. So all of this stuff at the bottom here is prices trending to nothing, and it's very difficult to make money in it. Communications layers, if you're Vodafone or EE or Deutsche Telekom and any number of other Verizon, any of these companies, they're basically saying this is a great opportunity because right now we've got complete saturation in cellular networks where there's not any more people out there who need to buy a smartphone, give or take. I mean, people are obviously recycling, kids are growing up and getting them and all the rest of it, but you're not going to triple the size of your market in the next few years. However, if you could put a SIM in every single device that's out there and charge somebody $1 a month to use it, then, well, hey, we'll be rich beyond the wildest dreams. But again, that comes back to the fact that you're not going to want to say, if I want to sensor enable my thermostat, I'm not going to want to spend £20 a year on a subscription just to be able to get data from it. It's just not, the utility versus cost is just not going to be there. So utility to me, that is. So that's probably not an area to make a lot of money in unless you can come up with a niche in that space. So there's a few companies I've dealt with who have come up with interesting ways of communicating over wired networks. So the wired network that is the power network that connects all your power devices together. And they've come up with ways of being able to signal data between those things. And again, it's one of those areas where they start off by saying, we've invented this technology, and at the moment it's $5 a unit to buy it, to make the chip that does it. But if we can get it to volume, it'll be 10 cents a unit. All we need to do is persuade every electronics manufacturer in the world to embed our chip in their thing, and let's see, Rodney, this time next year we'll be millionaires. And it's great in principle, but again, there's not an investor interest of Samsung and LG and Sony and everybody else to do that, so therefore it's hard to get off the ground unless you've got a lot of backing behind you. The areas that are probably more interesting are the ones that have the higher intrinsic value, and that could be in the infrastructure that ties all this lot together. But again, there's a lot of people competing in that space right now. Some of them are coming from a siloed approach where they say, we've got expertise in managing lots of devices and getting data off them and aggregating the connectivity and everything else. but that's an area that's getting quite mature in comparison to some of the others. The area to make money in is probably the place where you're saying, let us take the data that you're harvesting from the IoT environment and do something with it. So if you can figure a way out of mathematically using data that is just meaningless stats and coming up with something that means something to the people that have those machines, that's probably where they'll pay you more money than anywhere else. But interestingly enough, that is the area that's most divorced from IoT, because it's not really an IoT problem. It's a big data, data analytics, it's a machine learning, it's a AI, it's all of that stuff that's kind of not really IoT. But that's the pot of gold at the end of the rainbow, really, and that's why all of this stuff is happening.
So thank you very much, Henry, and of course, Ewan, for answering those questions. And there'll be lots more time at the end. We've got an expert panel Q&A with Ewan sitting on the panel. So if you've got any more questions for Ewan, there'll be time at the end then. So thanks very much for the finance question as well, or the money-related question, because it's a nice segue into the next session, which is about financing your Internet of Things idea. I'd like to introduce the finance panel up onto stage, if I may, and I'll just realised I gave all the chairs away, so I just have to get some more.